смена ведущего. Теперь буду...
Now we are changing the host. Now I'm going to be the host, and I will introduce people now after the break. I hope everyone is ready to continue listening. Now we will listen to Evgeny, who is going to talk about Apache Arrow.
Меня зовут Женя. Сегодня я вам
My name is Zhenya, and I'm going to talk about Apache Arrow. And
соответственно, это базовый кирпичик современного
this is the basic cornerstone for modern data
грузовики и другие
treatment. We create autonomous vehicles, autonomous trucks, and we use them to carry cargoes on Russian roads. And I am responsible for HD card. How is it different from the one that everyone has in their navigator? It is more detailed, everything to be able to move autonomously, and it is extremely precise. So it is no more than 10 centimeters. And it's similar to real-time systems. And probably in this conference, there would be people who would like to do the testing. And so where does the data management come in? And autonomous driving has a lot of data, and certain actors use that to exchange messages. Some of them collect raw data, some work with algorithms, and all of those things are put together on the hard disk on a computer. And then all of this is processed. And what volumes are we talking about? It's up to 7 terabytes during one drive. And this is per car, and we have a lot of those. And once they come to the hub, immediately the data goes into stream, and how we can use them. Definitely, we have the business big data, and this is calculating the metrics and also understanding the bottlenecks where we can tune it better. And so this is the high level of technology where you're looking for splitting the hair, if you will. EML tasks, preparing data sets and data visualization, and definitely building the maps. And Russia is a huge country with long roads, and so building one road even creates a lot of data. And we have a lot of infrastructure. We have a cloud provider, and that's where in S3 we have around 5 petabytes of data, and we rotate this data, and we delete what's not needed. And we also have a computer. A stack is quite big. It's all open source technologies. We are not using anything proprietary. We started with Spark, then we moved to Arrow and Spark, and more specific libraries for our tasks. So we have the task of processing a video. This is a video stream, and this is a sequence of frames for which we have to use a certain model. And the volumes are quite significant. If we are talking just about mapping, it's not about the other 200 cars. It is we will have 3 billion or 2 billion images for the summer. And what do we have to do? We want to have a sequence of pictures to process them, either in sequence or independently from each other. And definitely we want to launch machine learning on them. And we remember that there are 2 billion. If we were a streaming service, then we would keep them in the following, store them in the following way. We would have chunks of video data. We would take them through the machine to compress, and we would put them on a playlist, and then we would have a video the way it is, the streaming video. This is optimal for storage, but suboptimal for usage, because every time to get a picture, you will have to decode it, which is a non-trivial task, because you would need certain function, and it takes a lot of time, and this is suboptimal. And so the issue is, when we keep the issue, we don't have metadata, and we need the link between geodata and other data. What are the other options? Every file, every image, we can decode them once and keep it on S3. And this is good, and this is easy to read. But it's not convenient to list it. If you have listed millions of files in S3, you know what it is. And now we have issues with handling in S3. And for example, we have a PNG file and we do the compression, but still it will not be as high as in a video stream. So it doesn't work. And it could be something between the chunks of the video stream and separate files. We could decode the video stream and keep it inside Parquet as separate images. Then in Parquet, we will have the heavy column with PNG, but we can read it separately. And to get access to each of those, we could also use it for Parquets. And apart from this, we also get metadata. Parquet is an expandable format. You can add a column and use it. We have around 10 columns together with this block column. So the result is worse than a video stream, but in terms of using it, we can ignore it. And I said that we could do a lot of things with the Parquet. And one chunk of data is around 20 seconds, and then you put it into Parquet and PNG at the optimal size of 256 megabytes. But on-demand access is not so trivial. First of all, we have to back the data so that we could read minimum data when we read the rock group. For this, we need to reduce it to a smaller number of rows. Through trial and error, we came to the number of 5. And we also have to learn to read one row group and not to read the heavy column until we have filtrated everything we wanted. And we also don't want to download all the data in the files. So what we have for this, we have Apache Arrow, the one that I'm going to cover going forward. And very quickly, what are we doing? We created a data set with Parquet, and we have a certain scanner on it, and we write certain parameters. Then we read batches, and we take one element and we do non-trivial operations. For example, we could do something for OpenCV, and that's what we do for every row. And this is how it works. And we don't read the blobs, and we filter only according to light data. And now a little bit more about how it works and why and how we get these benefits. First and foremost, Arrow is a library, definitely a low level on the with the language of C++, and it is a standardized model to store data in the operational memory as a column, but not only, but it can also use 12 other languages of programming, and migration is possible between the languages, and you can write and read in all the languages. So interop is ensured. Apart from this, there is a strong compute engine and also mighty reading and recording and the protocol of data exchange of flight SQL. Now a little bit about how data works. Basically, all the types are similar to what you used in Spark and by Pandas, but the specifics are differentiating Arrow from everything else, and that's why it is so fast and optimal. The very basic brick there is Arrow memory buffer. This is the sequential part of the storage. It is typified, and the structure itself is as strongly packed as possible. And we keep here the Biden chain of all the rows. Now, how do the columns work? And we have the value buffer, and in case of a row column, there are all the rows. There is an offset buffer with all the offsets, and this is where our line is. And we also have the mask to identify which objects are null and which ones are non-null. And how is this different from what we had before? In Pandas or NumPy, the lines and complicated things are kept as objects, and we could have X20 overhead, and in Arrowhead we will have just X two overheads. That is doubling the operational memory. How do we handle this? We structured that into separate fields, and above them we have the structure of headlines where we keep the metadata, and in arrays we have the data itself. We have the structural column, and it has the bit mask, and it tells us if the whole element is null or non-null, like number 3. Then we break it into two, a row column and
маска, которая говорит null или null, вот эта строка.
they in one, and they have their
Там
own
хранятся данные. Вот. И, соответственно, в интовой колонке просто хранятся
masks,
данные в value.
which says or if it is null or not, and an offset is always 4 or 8, depending on the enter, and it is quite a rich library of types. And if the data
то мы их делим на
cannot fit into sequential memory, then we have a chunked array, and you can iterate through this. And now let's move to
такая
2D.
структура, как record batch,
And there is also the record batch, which is a set of record arrays, and there is a scheme and arrays. Each array has the same number of rows, and it is backed into the row group of Parquet as is, and they are easily handed between different processes when we are talking about column handover. There is also arrow table. Arrow table is the compound record batches and chunked arrays. And there is the compute engine, which is not very convenient, but you can live with it. If we don't read all the data in the memory, then we can set up the data set where we will have the filtration, the parceling, and we can turn it into the iterator of record batches, and or otherwise we can scan it. And scanning, like I said before, only reads the column that
фильтрует, получает
asked for in the scanner, and they get the numbers of rows, and then they read everything else that is needed. We can filter everything. This scheme ensures that we don't use operational memory when we read data. And like I have experimented with Parquet, it first reads the data and then starts filtering them if it cannot prune them. And pretty often it cannot prune the data. And that's not all of it. You can also handle the data with pluses. All of these primitives are available in all programming languages, but you can also implement that using just the pluses. And we did it at some point, and we write data in Parquet with Apache Arrow using pluses. Since we have the self-driving code on pluses, that's why we do it in pluses rather than in other languages. And that's what the data usually looks like for other companies, but that's what our data looks like. For example, it's there in the market labs, and we somehow have to do something. And we have something that is responsible for certain functions of self-driving, and we want to reuse it so that we can do data with C3. And how do we make sure that we marry pluses and Parquet? We write the package with pluses, and then we process the data. We don't want to write the exact pathways because it takes compilation. It's long and inconvenient, so we use the Python packaging, and then we transfer the data to pluses. Arrow has the mechanism of working which ensures that without copying and implementation, you can get data if you got it in pluses. And so the data itself is kept in pluses. And what we can do, we can get
ссылочку на таблицу, и в плюсах дальше
the link
написаны
to the
таблицы,
spreadsheet, and then in the
требования
pluses
язык,
we
конкретные
can
колонки.
retrieve
И вот здесь вот
specific
уже
rows
происходит
and
обработка
columns,
данных. По сути,
and
это все, что
that's
нужно,
where we handle the
чтобы
data.
сделать какую-то
In
сложную
essence,
работу
this is all we
непосредственно с
need to
колонками,
do
да, и
complicated
конкретным
work
рядом конкретной
with the
колонки.
columns
То есть мы
and
буквально
a
вытаскиваем
specific row of a
крупицы из этих
specific
паркетов.
column. So we are taking the necessary
Вот вы
grains
спросите, может
from
быть, если
these
Arrow
parquets.
такой крутой
So you
и
can
такие
ask me
позволяет
if
делать
Arrow
штуки
is so
очень
cool, and
быстро,
if
с
you
очень малой
can
памяти
do
расхода,
things
почему
like
просто не
that
выкинуть
really
все
fast
и не
with
перейти
little
полностью на Arrow?
storage
Дело в
capacity,
том, что
why don't you
просто
throw
очень
everything
тяжело
away
пользоваться.
and jump to
Это
Arrow?
низкоуровневая
Because it is
библиотека, в
hard
которой
to
есть
use.
только
This is
примитивы,
a low-level
вот те,
library
которые
with
перечислил,
just
да, там есть еще
primitives
некоторые,
that
но по
I
сути там нет
mentioned. There
SQL
are
языка,
some
там
more.
нет
There is
того
no
всего, чем привыкли
SQL
пользоваться
engine, all the
дата-инженеры в
other
повседневной
things
жизни, чтобы
that data
обрабатывать обычные данные.
engineers use daily
Поэтому,
to handle data.
поэтому, собственно,
So
нельзя просто выкинуть
this
ну,
is
тоже
why
там
you
Spark
cannot
или
just
Pandas, Polars и все остальное.
throw
Да, и
away a
на
Spark
самом деле,
or
куда пошла индустрия?
Planter
Индустрия пошла в
spoilers,
сторону того,
etc.
чтобы
And
встроить Arrow
where is the
почти как
industry
нод
going?
и
It
RAM
is
выдвижать
trying
во
to
во все остальные
embed Arrow
фреймворки, да,
as a
которые уже есть
compute
и которыми все
and
пользуются.
RAM
Вот здесь
engine into
схемка как
all
бы
the other
выглядит, да, то есть
frameworks that
для
others are using.
хранения
That's what it looks
долговременного
like
данных в том же
to
самом S3
long-term store the
используется
data
библиотека
in
FileManager,
S3. You
ну,
use
соответственно, для работы
the
с S3
library
и для
with
сохранения всей
Iceberg,
памяти. В
PUI
памяти у нас
Iceberg,
Arrow
and
слой, да,
we have
SQL-движков достаточно
Arrow
много,
layer
и они
in
используют
memory.
Arrow как
There are
compute-движок,
quite a
просто
lot
загоняют туда операции.
SQL
Вот.
engines,
И,
and
соответственно, естественно,
they use
данных когда много,
Arrow
да, хотим
as
их
a
считать на
compute
разных
engine.
нодах,
And when there
да,
is a lot
чтобы
of data and we want
побыстрее
to
как-нибудь вычислить. И,
calculate
соответственно,
them
появляется у
on
нас
different
слой
nodes,
распределенной
then
обработки.
we have the
Вот.
layer
Ну,
of
начнем
distributed
с
computing.
Pandas и его
Let's
распределенного
start
аналога. Да?
with Pandas
Почему я
and
вообще про него
Dasco, which
здесь
is a
рассказываю? Да, потому
distributed
что
analog.
DS
Why I'm
очень любят
talking about
Pandas.
this?
Их не будет
Because
никогда. Да, и Pandas
DSs
они будут
love
на них
Pandas,
швыряться.
and
Вот.
they
Соответственно,
would
проблема в том,
take
что
it
у
at
Pandas
any
куча
given
проблем,
time.
которые,
Pandas
собственно,
has
даже
a
создатель
lot
самого
of
Pandas
issues, and the
подсветил
creator of
в многих
Pandas
статьях. И,
highlighted
соответственно,
that
вот
in a
на
lot of
основе вот этих
articles,
вот проблем,
and
чтобы их
he
обойти,
offered
создал, поставил там несколько
something
человек,
to overcome those.
Apache Arrow.
He
И более
created
того,
Apache Arrow with a core
не
team of
просто
several
сделал Arrow,
people,
да, как
and
типа
not
вещь в
just
себе, но
did
еще и
they
потом
come with an
добился
arrow
того,
as a
чтобы как бы
thing in its
встроить
own
его
right, but they
Pandas
also
как
made sure
compute-движок.
that it
Вот. И,
embeds
соответственно,
in
что мы получаем,
Pandas
когда мы
as a compute
встроили
engine. What do we get
Arrow
when
в
we
Pandas?
have
Да, мы
embedded
получаем,
Arrow
во-первых,
into
нормальную работу
Pandas?
с нулами.
One,
Может быть,
we
если
get
кто-то
good
сталкивался,
work
да,
with
когда вы
nulls.
идентификатор
If you have
какой-то или
dealt
новый
with that
в
when
Pandas
you
получаете,
have
и вдруг
an
у вас появляется null, ваш
identifier
идентификатор
in
становится
Pandas,
флоу.
and then you
И,
have a null,
соответственно, начинает
and
куда-то
then
вычислить
your
конкретность.
identifier becomes null,
Вот. Дальше мы
and
получаем,
it
естественно,
dissolves and
ускорение
fails.
и
We also
снижение
get higher speed,
потребления памяти
and
там, до 5 раз. Может быть, иногда
we
и больше.
can reduce the memory
Есть
usage
вещи, которые уже
by the factor
реализованы
of 5. There are certain
чисто
things that
compute
have
на
been
Arrow. Есть вещи,
implemented,
которые не
and
реализованы, такие
this
как
is compute
группировка там
for
строковых
Arrow. There are
эксплошенов.
things
Ну,
that haven't
вот
been
это, к сожалению,
implemented
пока
yet,
еще не
such
готово.
as grouping
Когда
the
выкатывали Arrow в Pandas, да,
row
там была проблемка,
and
что все вещи, которые
mixed
не
types.
реализованы на
And
Arrow,
the issue
скатывались обратно в Pandas,
is
причем таким
that
образом, что
all the
происходило
things
копирование. И вот
that
здесь было
were
сильно
not
медленнее все.
done
Вот. Но
in
это быстро пофиксили.
Arrow
Вот. И, соответственно, сейчас
went
таких
back
проблем нет.
to Pandas and slowed
Распределенная
Pandas even more.
версия
Now
Pandas, да,
this has
такая как
been
Dasco,
resolved.
естественно, тоже
The
выигрывает. Вот Arrow,
distributed
в том
version
числе и
of
строковая агрегация тоже здесь выигрывает.
Arrow Dusk is also benefiting from the implementation. Now let's move to production. Everyone is using Spark executor, and we want to reuse the Spark IP because so that the computer would use less operational memory and work faster. And this whole thing is called Data Fusion. Data Fusion is also an Apache project, and this is an SQL engine based on Apache Arrow. It is based on Rust with the interface on Python and SQL. It was implemented in the way to make sure that it supports the maximum number of features for Spark. So there shouldn't be any migration issues. There are good icons there. And the creators of Data Fusion went a step further, and they made a plugin for Spark, which enables building the Data Fusion, embedding it into Spark as a compute engine, and we get a working solution, and then we use Data Fusion as a compute engine. The queries are still made by Data Catalyst. What it can, it moves to Data Fusion. What it cannot, it uses Java for it. And because of this, with the standard benchmark, it is twice faster than the standard Spark. But because you need the overhead for the distributed calculation compared to Data Fusion, it is somewhat slower, and not everything is yet implemented in Spark, Data Fusion, and Comet. And so sometimes you have to go back in Scala, and sometimes you use more operational memory. This is how Comet works, and the data is read with the native code in Data Fusion, and then everything that can be done in Data Fusion is done in Data Fusion. Then everything else that cannot be done there is done in Spark. Probably some of you have used that. There are also Pandas UDF, and this is an attempt to launch everything on Spark, but in a distributed mode. We take data from Spark, we read the data with Spark and feed them into Pandas, and then we do whatever we like, ML, computer vision, whatever, and all of this, starting from 2019, has been used. Can this be sped up through Data Fusion? No, not yet, because there is a call, and then to get the data back in UTF, there is the row column, and you want to work with column data rather than shifting the data around. What is available for this? There is Ballista engine, and we have Arrow, and we launch it with Ballista. Ballista is the framework of distributed data processing, and it is above Data Fusion, and it's implemented on Rust, no Java, no overhead, and the scheme is similar to Spark. There is a driver and an executor, and the handling happens in Data Fusion, and the communication between them happens with data flight, and the features there are obviously missing, and there is no UDF, which is much needed. There is also the framework called Polars. It is based on Rust plus Python, and it works on one machine. It's not distributed, but it is faster than everything else. It can convert into other frameworks of data, but that's not so important. And as different from Pandas and Spark, it combines the modes. We can calculate straight away, or we can come up with a plan, optimize it, and do it as fast as possible. Because of this, it is better. And it is fully in production. We are using it for some jobs instead of Spark. And the syntax is similar. There are certain nuances there, but it's not complicated to rewrite it. So what we get is an opportunity to work on one node, what we use several nodes for before. There is SQL, and there is the SQL, and you can use it. And there are nuances there, and they are still working the wrong way. And why? Because they use a really strange concept of window functions, and it is similar to Pandas, closer to Pandas. It asks you to sort everything out and to go through this. It's like done in shifts.
Просто неправильно работает. То есть вы не
So the SQL interface doesn't work correctly. It doesn't give you an error message, a runtime error message. No, you just get the wrong result. So if you bring it over to Polars, please pay attention to it. At the same time, the Polars primitives work really well. It's just that SQL is not been streamlined there. So why am I talking about that? Telling you about that. So currently, this is the fastest data processing framework on the market, and it saves you time, computing power, so you can bring some easy processes from Sparks to Polars, and it will save you some terabytes. Yeah. There is also a distributed version of the same product, but it's only in OVS. Right now, we can't use it currently. We don't want it. I mean, there is open source. Why should we use paid products? So there is another thing. It appeared in 2022, which is even better than Polars. It's framework of data processing on Rust and Python, and it's also distributed, unlike Polars, distributed by default. It has window functions, it has Python, and all necessary integrations. This product is being developed very rapidly right now, so let's talk about it a little more. What else does it have? You can work with ML in it. So basically, you can run ML codes on Daft's primitives, and you can view the pictures which it gives you, because initially, the framework was built to solve ML tasks. As I said, there is a distributed version that is running on Array platform. Array is a computing distributed platform, that is to say, sending the tasks for computing and then getting the results. So Array allows you to granularly adjust execution for each task. It will tell you how much resources, how much power it needs, disk space, and all that. So Array allows you to bring up subnodes and to scale the load dynamically. So what do we get as a result of that? We get the opportunity to take each UDF and see the resources needed by each batch. We don't see this in Spark. In Spark, we create a session once, and then we try to bring as many UDF as we can, so that as many as memory can hold. All this is done automatically. You don't have to recreate anything. You don't have to wait 20 seconds for Java. All of this is done as it goes during computing process. If something has dropped, you just change the resource and that's it. For instance, you change operation memory capacity twice, and then you set this function into all of the subsequent commands. All right, so let's draw some conclusions about Daft. So basically, we have everything that we need, and it's also quick and easy to use. So this, I think, is already a full-fledged substitution of Spark. And maybe in the next conference, I will tell you about that more. Unfortunately, it's not without nuances. It's all done on Rust. Rust developers love to create new libraries to rewrite everything from plus. So this is what they did. They rewrote everything Arrow on plus, and then they added some smoothly. So right now there is kind of this back migration to Apache of Arrow. So both Daft and Polars are based on this library, so they will have to migrate once upon a time. Hopefully the story will have a positive conclusion. All of this is for data processing, but to store data, we also need to store data, right? And we want to store them in Apache Iceberg in order to be able to do what Dmitry told you 1 hour ago. So that is to say, Iceberg is being implemented, including implementation in Russia. Iceberg is good for data storage and for retrieving the data, and Python is good for working with Iceberg. It's good for working with Iceberg tables. So what can we get as a result? We can get metadata, we can read the data, we can read it by the framework which we like, because we added all the integrations with all the frameworks I've spoken before. We can also write the data in Iceberg right there. So this is done on Arrow, strictly on Arrow. So let's draw some conclusions. So Arrow right now is used in all data processing frameworks that the industry uses right now. Which are up to date, unlike Highway, for instance. And what does it give you? It gives us the productivity boost and also sharp reduction of operating memory consumption. And once you bring that down, you can add computing power by increasing the number of cores that are computing your data. Arrow is being implemented, as I said. Every time when you download a framework, you also download Arrow. All of this goes towards unification. I think that, generally speaking, frameworks are going towards unification. There is difference of layout and all that, but if you basically change all of your drives into Arrow, you'll get the same thing. Of course, we'd like to have a nicer looking shell, but that's in the process. Unfortunately, Rust and the whole structure of Arrow development and the development of Arrow-based libraries is not without its problems, but the previous iteration that we saw, when we had Java-based frameworks and libraries, all of them were Apache, and they basically all disappeared. We only have Sparks which survived. So 10 years ago, we had about 30 libraries.
Здесь, может быть, даже их и поменьше еще. Ну, может быть,
So maybe here we even have fewer.
вот.
Yeah,
Но
but maybe
хочется
some will
чё
write,
получить, да?
somebody will
Хочется
write a new
получить,
library. What do we want?
фреймворк, допустим,
We
ладно,
want to have a
но чтобы он,
ready-made
во-первых, поддерживался, да,
framework.
во-вторых,
Okay, let it be on
всё, что
Rust, but it
поддерживает,
has to be
например, хотя бы
supported.
Spark.
It has to support everything that right now Spark is
Быстрее
supporting.
работал и меньше оперативки тратил.
And of course, we would like it to work faster and use less operating memory.
Arrow активно развивается сам по себе.
Arrow is developing very actively by itself, and everything that is based on Arrow is developing too. I'm talking here about data fusion and Daft. And while I was preparing this presentation, the Daft introduced to window functions,
Когда вы качаете Pandas 2.0, вы качаете
pop-up
еще
window
Arrow.
functions. So every time you download Pandas to 0, you download Arrow as well. So let's dream a little bit right now.
Может быть, в следующем году, может быть, через 2 года.
I hope that next year, maybe
Который будет
2 years
соответствовать совсем
from now, there will be a framework which will support absolutely everything and will have a pleasant and fast working process. This is all I had. Thank you very much for your attention. I'm ready to entertain your questions.
У нас микрофоны справа и слева.
Okay, now please use microphones for your questions. Microphones are on the left and on the right.
Здравствуйте, спасибо за доклад. Да, у меня такой вопрос, а почему вы используете паркет?
My question is this.
Ведь в ОРЦ у него вроде и сжатие.
Why do you use Parquet rather than ORC?
У него там встроено.
Compression and index in ORC is much better,
Вот такой вопрос.
isn't it? So that's my question. Why Parquet rather than ORC? ORC has less integration with it. All the frameworks that I've mentioned, not all of them will work with ORC. Whereas with, yes, I mean, we can write everything in pluses, and org has all standard libraries written on pluses, but then we won't get to the features that we have in Parquet. What do we need from Parquet sometimes, and why are we still using Parquet?
На самом деле, Data Lake тоже я начинал строить, вот, это сейчас начал заниматься.
That was a while ago. But anyway, what kind of specificity we have? We run the plus classes into the structure of Parquet, whereas developers, the plus real-time developers, like to add new strings, new things, and it's very hard to do in the worker, at least and in Parquet, it allows you to add or delete columns to change their so Parquet has a better support. Work is compressing better, ORC is compressing better, but maybe it has a better structure. But if we talk about evolution scheme, it's kind of heavy. So if we don't take media data, which is video, which doesn't change scheme-wise, but everything else, for instance, the algorithm outcome, it changes a lot. And you have to unpackage the scheme, you have to delete something, you have to add something. And we have these functions automated, right? So we have about 200 tables, and we don't want to support them manually. Everything is done automatically. We wouldn't be able to do that on ORC.
Вопросы?
More questions?
Слишком сложно, да?
Too difficult, isn't it?
Дим, ты задашь, да?
Dimitri, you're going to ask a question, I guess.
Я не знаю, на самом деле. Ну вот, короче, вот этот есть Arrow у нас.
Okay, so we have Arrow,
Chunked array. И как мы
and
знаем,
it has chunked arrays.
вот виртуальная
And in operational systems,
то есть, ну,
memory
памяти, они на самом деле,
blocks are
ну, которые логически расположены рядом,
logically they're together, but physically they are elsewhere. So Arrow in real time in operational systems, will it work faster or not, given this? Well, I haven't computed that, but I think so. Yeah, it might, because the block is all located in one space, in one spot. Okay, then another question. If we don't talk about analytics, but if we talk about real-time systems, is Arrow used in real-time systems? Well, we write all data that goes into Parquet in Arrow. So all data that comes in real time is collected into a buffer, then the buffer is going to Parquet. No, that's not what I mean. Let's say there is a car that is driving, the sensors are taking some pictures, sending it. So in real time, we have to do some analytics. How many kilometers have been traveled? In other words, we have to do some analytics that is not based on the inside system. Can you use Arrow for that? Yes, but we don't give any computing power for that, because computing power right now is limited. So to drive in, this driving needs all the resources that you have, right? So developers will take all of them. And then there is nothing left for analytics. So analytics is done in click. When the car is just sending you telemetry, right? So the first versions of analytics were built on click. Yeah, you can do it. The question is why? Bulk of work in real time basically is implemented in row constructions, not in column constructions, column structures, rather. And other than that, yeah. I also have a question. You mentioned data fusion. You mentioned the strings and the way they are organized in memory, in Arrow's memory layout. Now, in data fusion, one Chinese expert, he put what is called the German string, this optimization and storage of strings in order to not just look for them again when you operate with them. Do you think Arrow will incorporate this this feature, or will it remain strictly in Fusion? Arrow also has string view, yeah, but it's implemented differently. It's as if all the strings have been glued, and then if we talk on offsets, you have to do something else. When we speak about the German string, there is a prefix that is stored separately that allows you to look for the strings quicker. If you want to inline a string, you can do it. If not, it's dropped into the table. So it's a fancier system. Are you familiar with it? No, unfortunately, I'm not. But maybe, yeah, maybe they'll incorporate it. So the task is to allocate less power, computing power, when you work with strings. And in Spark, MR, well, not a issue, there is definitely an issue. Does Arrow have an issue with it? If we're talking about pluses, you can get a buffer and use this buffer as a memory block. You don't have to allocate anything. Yeah, but later on you'll have to read it, retrieve it, do something with it. You won't be able to do it without allocation, will you? No, I mean, you will be able to read it, but you won't be able to do an operation. But anyway, okay, let's forget about it. It's an interesting subject, though. There is a blog that used to be Chinese. Now they brought it into data fusion. I'll give you a link. It's very interesting. Any questions? Any more questions? Well, it looks like it. So the best question, according to you? I like the questions about O or C. Yeah, true. These formats look alike, and the choice is not always apparent. Okay, please come up to the stage for the present, for the award, for the prize.
Спасибо за вопрос.
Thank you very much for your question.
Ну, кажется, у нас все, и мы, наверное, готовы к
Okay, well,
следующему докладу. Спасибо, Жень.
That's it, I think. If this is indeed so, then we'll invite the next speaker on stage. Thank you. Thank you, Eugene.